Go. All right. So now what we need to do is we're finishing off lesson 3. So we're asked to evaluate this integral. It's recording, isn't it? Good. So evaluate this integral. So remember to do this, we're doing it non-calc. So there's a little bit above. So if we happen to pop this in the calculator, a little bit of this area will come up as being positive or negative.
Positive.
And would this area come up as being positive or negative? Negative, yep. Here, are they asking us for the area between the curve and the x-axis, the shaded area, or are they asking us for something else? Yeah, they just want us to find the integral.
Yeah.
If they just want us to find the integral, you leave this one positive and you leave this one negative. But
as opposed to the
yeah,
okay.
and it's when they actually say find the shaded area, see, that's when you do need to put them both in as positive. Find the area between the curve and the x-axis, like the shaded area, that's when you have to put this one in as a positive. If they just want the integral, then you leave this negative and leave this one positive. Nice. And what's great about it is when you pop it in the calculator, it does calculate this as a negative and this as a positive. So we don't need to work out two integrals. We don't need to work out this one first and this one because it's fine. You can just work it all out together, like from 0 to 3, because it's automatically going to consider this as negative and this as positive. But when we're doing the one down below where we have to find the area, we need to break it up into two parts, the positive part and the negative part, separately calculate those, and then add them together as if they're both positives. So that's going to be a bit more work. But that one we can do with calculator because it's more work. So to start with, we work out the integral. So let's work out the little integral. X cubed, it's not a composite function or anything quirky like that, so just separately integrate each term. X cubed, what would that become?
X4.
Yeah, x4.
Over 4.
Over 4, yeah.
I guess confused between integrating and
It is, yeah, and that happens, yeah.
yeah.
The brain gets muddled between them, especially when you've been doing an assignment. It's got a bit of both. While you're writing that down, I'll quickly do this again. It's already gone out.
I like it by hand.
Yeah, by hand. This feels like understandable, doesn't it? Minus 4x squared.
4x
Good. 4x cubed over 3. And then plus 3x, what would that become?
x squared over 2.
Yeah. Do any of those simplify or anything?
Yeah, no, sorry.
Nah, yeah, like say if it was 4x cubed over 2, you could simplify that to 2x cubed. But none of those break down. When we're just asked to evaluate the integral between two x values, we don't bother with the plus c, because these are called definite integrals. Meaning, you can sub in, you don't need to work out the plus c, and you can sub in some x values and solve. So once you've kind of done that, remember the kind of notation is, you've got the integral, so you put little square brackets around it, and the boundaries, the lower limit and the upper limit, you just pop on the side here. This is the notation that we generally use. 0, that is not quite in the wrong spot because of the calibration. It's meant to be sort of like, it's next to it like that. It's meant to be at the top. That's the won't go. What was your question, Michelle?
So this is a definite one.
Yeah, this is what's called a definite integral. Like basically no plus c at the end. There's no unknown constant at the end. So what you do is you integrate, pop the integral in the square brackets, and you just remind yourself of what the lower and the upper limit is. So in the square brackets, you always put the integral, not the original function. And then you just sub in the upper limit first, calculate that answer.
And make sure those are in brackets.
Yeah, exactly. And then subtract the lower limit subbed in. And putting it in brackets is important too. Like put with the 3 subbed in, put it in brackets, work out that whole answer. Work out the whole answer to the one with 0 subbed in, and then subtract.
You still can't use calculators?
Yeah, let's do it non-calc still. So you're going to get, it's good practice of your fractions actually. Doing it this way. Yeah?
How do you know whether it's definite differences?
Definitely, see that 0, 3 is automatically, you just got to be definite, yeah. Like whereas in the topic assignment, notice sometimes there was no upper or lower limit. They just said find this. So therefore, and they didn't give you a coordinate or anything. So therefore, all you could do is like sub in plus c at the end. Whereas here, when it's kind of like you've got these things, you don't bother with the plus c. Because in a sense, it's just not important because it's going to subtract. The constants are going to cancel. When you sub in 3, then sub in 0, the constants are going to cancel out anyway. So that's why we just don't bother with the plus c, because the plus c is going to cancel out. You're going to have plus c here, minus plus c, so it's going to go. So now we pop it in. So yeah, so now we separately pop everything in brackets. So it's going to be 3, 4 to the 4 over 4 minus 4. So it's good practice of non-calc skills. Tell me if you disagree with anything I've put on. Put it in brackets is a good idea, as we said, because otherwise it's easy to go off track. Now we'll sub in 0.
I think because that's not, that's not.
Oh, go away. Seriously. Okay.
80 divided by 4 is 20, so 10.2. Bro, 27 times 4. Yeah, Sarah. You go, girl. Thanks.
3 to the 4, yeah, what's that?
She said no.
Huh? So 81.
108.
Tell me if you disagree with me.
I bet you used a calculator, Miss Ryan.
Oh, I don't know. No, actually I didn't. So don't necessarily believe anything I've written. So what's interesting about the second bracket?
They're all just zeros.
Yeah, they're all just zeros. So it's just going to be minus 0 for that one. That's nice. So in a way, all we've got to do is work out the left bracket, and that's going to be our answer. Oh,
108 divided by 3.
how did I do this? Oh yeah, 108 divided by 3 is a nice whole number.
I know, but I don't know what it is.
Yeah.
Oh, 8, what gives you 18? It would be a 6. How's it end to a 6?
Yeah, it will. So what's 90 divided by 3 then?
Oh, it would be 56. No, 36.
Yeah, you could make them over 12 as
It's
well.
36.
Make them all over 12. 36, yeah. So this just becomes a nice whole number. See?
27 divided by 2 will give you 13.5.
Yeah, 13.5 if you want.
How was it 36? 108.
Because she.
How did
You know it's a multiple of 3 because 1 plus 0 plus 8 is 9. So if the sum of the digits a multiple of 3.
What?
Yeah, if the digits add up to a multiple of 3,
Yeah.
you know it's divisible by 3. It's a
No way.
It's like 321. 321 is divisible by 3. Plus, you could do like 13.5 if you want. I don't know why that came up the screen.
If you put 13.5.
So 81 divided by 4, I just put in a... You can take them close, 24, yeah, 20.25, yep. You could do, I did 20 and a quarter, minus 36, plus 13 and a half. You could try this if you want, like you can turn them into, or you could turn them into like common denominators, that's also okay.
No, I just added them.
Is it okay if I sit there? Because it's going to be a headache.
Sit here.
There.
No. Because I've got to be able to go from here to here to be able to see to scroll down, because the scroll on the board's just so off. Otherwise I could just do it on the board.
So negative 4.
Yeah.
I got.
Yeah, 20 and a quarter. You could try
Can't use my calculator.
You could try adding these together first if you want. Would that easier? Yeah. What would that give you?
I got 69.75. What?
What?
What would you get?
Wait,
20
no,
and a quarter?
to me.
29.25.
Oh, it's a subtract sign. I'm sorry.
20 and a quarter plus 13 and a half. I'm adding these two. I'm adding the two positives.
20.
What's 20 and a quarter plus 13 and a half?
It's like negative 2.
No, what?
20 and a quarter?
33.75.
33.75, yeah.
That's what I did. 33 and 3/4.
Yeah, 33 and 3/4, yeah.
No grade.
Minus 36. What's that going to give us?
And then 2.25.
Negative 3.75.
Minus 0. Can't forget that.
Negative 3.75, didn't it?
Thanks. I was right.
Yeah, why is that?
Why is this door frame?
No, same.
Yeah, why is it that?
What about negative 0?
That's like. Who said what about the negative 0?
That was me. I'm confused.
Subtracting 0 doesn't.
I know, I was just getting confused. Fine.
You could have, yeah. But someone was asking about the 0, so I thought, okay, I'll just bring it down. Yeah, get rid of it, yeah. Don't worry about, if you're happy with that, realizing that, then don't worry
Wait,
about
but
that.
can you just explain what this answer means?
Yeah, can someone explain, like, Talise,
3.25.
how did you get negative 2.25?
You just do 36 and then take away that number and make it negative.
No, what it means.
Oh, what did the question ask for?
It just said evaluate.
Yeah.
So that means that's
Owen. Yeah, but this is hard, so you want to listen. Yeah. Yeah, what does it, you mean, like, what is that thing found? Anyone want to have a go at saying?
What have you found?
Yeah, what does that number mean?
Isn't it the definite integral of that?
Yeah. So what it means is, if you worked out this area and you got a positive number, which you will have, and if you worked out that area and you got the negative number, and you added those two numbers together.
Oh, okay. So it's the area, but not the area.
So the
Yeah.
difference can be
The area, but not the area. So if you calculated this area, you'd get a positive number. Would you agree?
Yeah.
If you worked out that area, you'd get a negative number.
We can just get negative overall number because that area is bigger.
Because we did.
Yeah.
Okay.
So basically what we
Yeah,
found was
yeah,
the two
which
areas
makes sense, yeah.
combined.
Yeah, we found the two areas combined, but we kept this one as a negative.
Okay.
Whereas when we do part 2, we're going to find the two areas combined, but we have to keep that one a positive. If it just wants the integral, then you leave this area negative. But in a way, when you do the whole thing all together, it puts this as a negative anyway. So you can just do the whole thing all together. But when you want the area, like it asks for down here instead, the shaded area, you've got to separately work out that bit and that bit and add it together. But notice here, to make life easier, I said you can use calculators to do it. Just because we want to practice using calculators too anyway.
Wait, so the area is not.
The area is not this. Because this thing kept putting that as a negative. But when we're calculating the areas, we need to use the absolute value. Because in the real world, you can't have a negative area. You can have a negative integral, but if it's talking about the area as an actual thing, a real thing.
So you can't just change the sign. It's like a completely different thing.
Nah, yeah. Because that negative 2.5 is that one and that one added together.
Okay.
So instead we have to separately, I'll show you what we have to do. We have to evaluate, like here's your graph thing, whatever it was. We have to evaluate this bit on the calculator, and then we have to evaluate this bit on the calculator and make that one positive. And then add them together. Like take the absolute value, because in our universe there's no such thing as a negative area. Whereas before it was talking about a more abstract concept, which is the definite integral, but here it's talking about a concrete real thing, like an actual area. So we just have to find the two integrals separately, but we can do it with calc, and it's good to practice with calc. So, right, I'm looking at the wrong page now. Oh right, yeah, I did do it. I just couldn't see my other thing on here. So we've got two different ones. So this area is between 0 and
1.
0 and 1, yep. So remember, lower limit down here, upper limit down here. Then you just write the function. X cubed minus 4x squared plus 3x brackets dx. And then we're going to find out what that answer is with our calculator.
Oh, you said x squared. I was thinking here.
Oh, yeah, so 4x squared, yeah. X cubed minus 4x squared plus 3x. And then we're going to work out, oh, that was meant to be the blue area. Sorry, I should have done that in blue. I've done it in the wrong order. Okay, so that's the blue one. This is the green one. The green one's between 1 and 3. 1 and 3, yeah. And then it's the same thing. X cubed minus 4x squared plus 3x dx. Work that out, and you'll get a positive answer for this first one and a negative answer for that one.
Yeah.
fraction.
I don't know. This calculator doesn't.
Just go math fraction. Just press math fraction. Math 1.
Isn't it big how we can put a number in the calculator?
Yeah, sorry. Yes. Did you press math fraction?
It says small.
Yeah. Okay.
It's just press math fraction.
Yeah, press math fraction. It turns it into a nice fraction for you. Oh,
You learn something new every day.
math fraction. So 5 out of 12 is what we got for that one. And then we're going to see what we get for the other one. Put it as a negative to start with, and then on the next line we'll add the two absolute values together. So then you pop that in the calculator. What did you do to do that? Just to remind people how we get that on the calculator. Yeah, good. That's right. Math.
Melanie, what did you say to put as a negative?
Math 9. Oh, just 1 second. So then, do you know how to do this, Talise? So put it in the calculator? Oh, God. Okay. Yeah, and so that's how you did it. And then this is the one. Have you popped this one in the calculator yet?
Yeah.
Okay, yeah. So this is going to come out as negative.
Yeah.
And then we write down the negative answer here. Let's see what it is as a fraction. Let's practice out.
Negative 8 over 3.
Negative 8 over 3. Good. And so,
To subtract them or add them?
yeah, we add the absolute values of them together.
So you have to.
Because in a sense, the area is going to be the blue one plus the green one. Yeah. So, and the green one we just put in as a
So
positive.
you make it positive and then make it the common denominator?
Yeah. Equals, yeah, good. 5 over 12 plus 8 over 3. So make a little note to yourself.
37 over 12.
Yay, 37 over 12. Such a gross number. So yeah, make a little note down here. Note. We have to use the positive or the absolute value. Remember, absolute value means the positive. As area cannot be negative.
I think an outside over there.
Feel free to add some extra notes too, like, for example, we need to work out each area separately and add them together. So maybe I'll write that here. Add the two areas together to get total area. So when you look back, you see, understand what you're doing. Add the two areas together to get the total area. And then what do you get, Sarah? 37 over 12. You're just fine. And if you need units, you just write square units. Or unit squared, yeah. Square units or unit squared. Yeah, it's hard. You're trying to write and process at the same time, so it is hard to. It's good that you ask questions because writing sometimes gets in the way of the processing.
You're a good girl.
Thank you.
I know more outside school.
Let's do it after I do because right now it's
No, sorry, that's just. I try.
You're very good. You're very good at hiding your stress.
You
You must internalize it quite well.
We're pretty used to
Wait
it.
until we get in the conference room.
And then you go nuts. So I need to kick out every mate, or else I'll be hearing about it.
I was talking to the Ivy ones and they're crying right now.
About what?
We cried.
No, we
didn't.
Last year,
I was
We had the
enjoying
IOP
life.
this time last year.
And Lauren was a
I
nice
think Armstrong one was probably the best thing ever.
IOP
Yeah.
was so much easier compared to this dumb IOP.
Yeah.
It was so much easier.
IOP was scary.
Yeah.
Lauren it was amplified, so I was like,
Actually?
Yeah, I
guess
guess
that's
that's
how I played it out.
Where'd you get Barrett?
Is anyone still writing? That's okay.
told me to.
All right. So here we go. So this is a nice little example. Just pointing out that it says use geometric formula. This is possible. They could ask you this to evaluate this. This is just testing that you realize you could just calculate these areas using geometry, and that will give you this definite integral. So that's what it's testing, do you realize, like, some people might look at it and go, what? It's just testing that you realize this thing equates to the area under the curve. But what's interesting is, did they ask us specifically find the area? No. Yeah, evaluate the yeah, good. So keep this one negative and keep this one positive when you add them. Yeah. So that's a good point. They just said find the definite integral. So we're going to calculate the areas and keep this one as a negative and add that one. Yeah. Oh, you're stretching.
No,
Hey, question.
how come the heights don't matter? Like we would have put them as 4 on a Y. You feel me?
No.
Like, how come we don't take this into consideration that it goes up by 4? We just use the width.
No, we didn't. We're going to. So yeah. Well, still, I haven't started to answer the question yet. So what kind of shape is this little thing down here? It's a triangle. What shape is this? Yeah, trapezoid. Yeah,
So how come
trapezoid.
it's 2 different colors?
I think they thought you could do a rectangle, and so you could do a rectangle, a triangle, and a triangle.
I know that.
I did that too.
That maybe but yeah, like you don't want to forget how to find the area of a trapezoid either.
Because you always just split it into rectangles.
That would be. You could only do that, Grace, if you had these numbers down here, like you knew exactly that length and exactly that length. But quite often they don't tell you. They'll tell you the entire length. I suppose they'll tell you that one though, wouldn't they? Yeah. So yeah, you could work it out. But some trapezoids aren't set out nice, like like this one. Sometimes they're set out like that, like as in they're like this, like that kind of thing.
Oh, so you're saying it won't always be like this shape?
Yeah, you might not know.
No, that's
Irregular.
because technically as long as they have 2 parallel lines, that's all that matters.
Yeah,
That's
and these are your
annoying.
parallel lines. Yeah, so it's a trapezoid.
If
So
if
yeah,
those
keep going.
parallel, is it a rhombus?
That's a parallelogram.
Yeah, parallelogram. Yeah. And a rhombus is a specific type of parallelogram where all 4 sides are the same length. Yeah, that's parallelogram. So it's going to be a trapezoid plus a triangle, and the triangle is negative. Negative as below. So we're going to put the triangle one in as a negative. So in a way, think of that as like the area of a trapezoid or trapezium, whichever one you want to use,
So would it be minus?
plus the negative area of the triangle. Yeah. Yeah. So in a way, if you realise plus minus is minus overall, you can put it in as minus. So it's the area of a trapezoid plus the negative of the area of the triangle. And the trapezoid, what's its height?
4.
4, good. Yeah, you can just get that from the graph. Okay, I'll just have to pause. Yeah, you guys go ahead and keep working that out. So you guys go ahead and do that, because I've just got to pause and we're recording again. So to find the area of a trapezoid, you find the average of the 2 parallel sides. So you add them together and divide by 2 to find the average, and you multiply it by the height. And the height has to be at right angles to the base. Trapezoid, so we've got 4, the length on the bottom is 7, is it? Yeah. And the length on the top is it 3?
3.
Yeah, cool. And the base and the height, 2 and 3. No, it's 2.
4.
Oh,
The
2,
height?
Yeah, you're right, 2.
2 and 2, yeah.
Or you could put plus and just put in the height as being negative. Yeah, you could totally do that. Either way, just so long as overall you end up subtracting the area of the triangle. Whichever way you want to set it up, you go for it. Nice. So yeah, so we've got to go 7 plus 3 divided by 2. That's the average of the parallel sides, and you times it by the height. Plus, how do you find the area of a triangle?
Base over 2.
Yeah, based on the side over 2. And then you get, what did you get overall for the trapezoid? It's negative overall for that. Did you get 20? So 20 plus negative 2, that's 20 minus 2.
But you didn't multiply it by 2.
What? Oh yeah, I did the little 4 out here. So it's good, in a way it was good to practice a trapezoid because you might be asked to calculate a trapezoidal volume of a trapezoidal prism in the exam or something. Do you remember when we first did the at the very beginning of this unit, we had to do like background knowledge? And one of them was find the area of a trapezoid.
Yes.
And this is why. Yep, because of this thing. And some of them were like work out this sequence and that kind of thing. Now what did I ask you at the bottom? Find the area between the curve and the x-axis. So in a way we've calculated some things. So instead of doing, what's the area of the trapezoid? 20. What's the area of the triangle?
-2. -2.
Oh, can you have a negative area?
2.
2, yeah. So it's that kind of thing. So that's why I've given you a range of questions. Somewhere they just want the definite integral. So you might want to make a note. This is just a definite integral, not the area. So a definite integral, you can have a negative because it's just an abstract concept. Whereas when they word it like find the area is a concrete concept, a real life concept, so we can't have a negative area. So when they want the... Oh, do you want me to go back up?
Yeah.
There you go, yeah. So just a definite integral, not the area, is what they were asking for here.
So for the next one, we just add these two together?
Yeah. So what would it be?
22.
22, yeah. So you don't need to go and show the
Unit
working out
squared.
again. Just go, yeah. Unit squared, squared units, yep. So it says just a definite integral, not the area between the curve and the x-axis. So add together the absolute values of each area. Absolute value of each area. So it's going to be the area of the trapezoid, trapezium, plus the area of a triangle equals 20 plus 2 equals 22. 22 square units if you want to write it as these. Dun, dun, dun. Dun, dun. Isn't it from the 80s or 90s?
Yeah.
Dun, dun, dun. I think it's 90s. Is it like
It's
Massive
reggae.
Attack or something?
I was
No,
gonna say
no. Oh, but I bet Massive
you
Attack
don't
did a cover of an old song.
Oh, so you didn't know reggae?
Yeah,
You just
no, I
knew
don't think
cover.
so, no.
You let me know.
Yeah, because I think this dub, everything dub was very popular in the 90s.
I wasn't even thought of it.
Oh yeah, you millennials. Holy moly.
We're the I
Your
generation.
regeneration,
you're
regeneration,
the
eh?
millennial, right?
No, I'm just after Generation X. I was just a little bit late. I was on the very end of Generation
Is
X, maybe.
Generation X the baby boom generation?
Yeah.
No, that's not the other one.
I'm married.
No.
All the generations.
My parents are like,
Oh, okay, we'll finish there.
like 15 to like 55. Or like,